So, you all have made it to your last lesson of Math 1. Woo! So, we're talking about, to wrap up this year, this unit, talking about the shape of distributions. Distributions just referring to histograms or box plots, any of those visual representations we used to represent our data with a picture. So, if you're looking at a histogram, and histograms are typically the biggest ones or the most often used with this vocabulary. So we use 3 different vocab words to talk about the way a histogram looks and what the data in the histogram might be doing. So we can either say it's symmetric, that very bottom one, or that it's skewed either to the left or skewed to the right. So let's look at the symmetric one first. If it's symmetric, looking at this picture right here, it's pretty balanced, right? If we were to take that little box and fold it in half, the one side would pretty much map out to the other side. There won't always be perfectly balanced, like they won't always be exactly matching up, but they'll usually be pretty close to this. I mean, these match up pretty much exactly, but more often than not, they'll be a little bit off, but you'll still be able to tell that they're pretty balanced. So if you're looking at something that's symmetric, the data is balanced or almost exactly balanced. Won't always be perfect, but usually you'll see it pretty close. Okay. If you're skewed left, and this seems kind of backwards, but if you're skewed left, most of the data in that distribution is on the right. And if you're skewed right, most of the data is on, let me do that in a different color. Most of the data is on the left. So let's look at a little trick to help us figure out and kind of sort if it's skewed left or skewed right. So if you're skewed left, most of the data is on the right. And what I like to do to help me remember is I like to follow where most of the data is. I make a little arrow following the shape of the bars. Most of the data is on the on the right, and then it's skewed. Notice how the arrow is pointing to the left. The rest of the data is pointing to the left. For skewed right, most of the data is right here, and if I make an arrow to follow the rest of the data, that arrow is pointing to the right, so it's skewed right. The tail is pointing off to the right on this guy. The tail is pointing off to the left on this guy, so that can tell you which way it's skewed to help, because it can be kind of backwards if you just look at the definition. Okay, so let's keep going here. Let's look at an example. So what if you're asked to draw a frequency table? If I can zoom out a little. What if you're asked to draw a frequency table and then analyze it? Well, let's do that together. So we're asked to make a histogram of the number of tickets sold for some event. I'm going to make it purple. So the intervals on this down here might look a little bit different than the ones you might have practiced when we did the histogram assignment, but hopefully it's not too complicated. So our frequency, notice it's right here. That's just going to tell us how high the bars need to be. So for the interval 1 to 8, I need to make it 5 high. So I'm just going to color in right here. This is my bar for 1 to 8. It goes all the way up to 5, just like that. For 9 to 16, which is the next one over, it needs to go all the way up to 9, which is probably going to be about right there. Make a bar, color it in. And on your assignment, you're going to have little bars that you can stretch out and make it as tall as you need to. Okay, on mine, I'm just drawing for right now. So 17 to 24 needs to be 16 high, which is about right here. 25 to 32 is 25 high. 33 to 40 is 20 high right there. 41 to 48 is about 8 right there. 49 to 56 is 7, so it should be 1 lower. All right, so if I'm going to color the rest of these in, if we're looking at it, if we're look at letter B down here, What's the shape of the distribution? We have three options. It's either going to be symmetric, going to be balanced, or pretty close to being perfectly balanced. It's either going to be symmetric or it's going to be skewed to the left or skewed to the right. We have those three options. So if I'm looking at this, even though it's not perfect, if we look at the two outside bars right here, the 1 through 8 and 49 through 46, those don't match up perfectly. But I have one big bar here in the center, and then most of it goes that way, but then I have some of it going that way too. I would say this is symmetric. Most of the data is not just on the left or just on the right. It's pretty balanced. And I forgot how to spell symmetric. So that's my shape, pretty balanced. It doesn't have to be perfect, but if it looks like most of the data is not just clumped on the left or clumped on the right, you're probably going to have a symmetric. The other representation, we're learning a new representation today. It's a stem and leaf plot, and it's kind of like a histogram, except they make it with numbers. So a stem and leaf plot is a plot where each data value is split into a leaf, and a stem. The leaf is usually the last digit of the number, and the stem is usually whatever other numbers are left. So stem and leaf plots are convenient because they visually show the distribution of a set of numbers, and you can see all of the numbers that are in the data set. So it says determine which plot is right skewed, left skewed, and symmetric. So just to be a little more clear, for this stem right here, you'll see they have these keys. So like if I'm looking at this top row right here, the 1 represents like the tens place, and because the key tells us that we're dealing with numbers that have a tens place. So I have 11, that's the stem is 1, the leaf is right there, that 1 right there. I have another 11 because I have the second one right there. And then I'm going to use my stem still. I have a 1, and one of the leaves is 13. And then one of the leaves is 14, and then one of the leaves is 18. So they all start with 1s, and the leaves tell you what the 1s place should be. That's kind of what that means there. So if I went to the next one, I would have 22, because the beginning numbers are going to be a 2, and then I have a 22, and then a 23, and then a 24, etc. Okay. So we want to see, we need to determine, because there's one of each, which one is symmetric, which one is left, and which one is right. Pause the video and see if you can decide for yourself, but this is what we have. Over here, I notice that a lot of the numbers clump up this way, and if I make an arrow that follows this, you kind of have to turn your head to the side. But notice if you were to flip this, we would have an arrow pointing to the right. This one would be right skewed. If I look at the second one, most of the data that I see, the highest points of the data are like right here in the middle, and then it goes that way, but I also have some going this way. I would say this middle one is symmetric. And then if I look at the last one, I have a lot of data. The tall data right here, the tall bars, if you will, are over here on the right-hand side if you're tilting your head. And then the arrow kind of follows that way. And if I did it this way, right, this would be a left skew because the arrow is pointing to the left. So there you have it. You're going to have a practice assignment with this where you're going to have to drag the bars. Since you can't really color it in, you probably don't have a touch screen, or you might not. But it wants to know at the end of the day, what shape do these distributions have? Okay? We didn't talk about box plots, but think about the same idea. The box in a box plot tells you where most of the data is. So if your box plot is way out here and you have a giant tail going this way on a box plot, that would be a right skew. If your box is right in the center of your number line, that one would probably be symmetric. If your box is all the way out here, and most of it is trailing that way, or you have some numbers trailing that way, that would be, it's pointing to the left, a left skew. All right. Ask questions if you need to, please, please, please. I'm here to answer your questions. I just need to know what exactly you have questions on. That would be very helpful to me. Good luck. Have a great Monday. May the 4th be with you, and we'll see you.